I'm doing a bit more work on the GUI for Matlab's interface to the lumascope. It's night time, so here we have an image. Looks good, and we can pan around. So we will close LumaView, and then we'll open up Matlab. The first thing is initialization, ls init. Takes a few seconds. I think I figured out how to get this working right all the time, but always check still. Image equals ls get image buffer, and guess I don't have it because it doesn't work. Edit ls init, and we're just gonna try this stuff again. Image, and this time we got it. And the GUI has two components now. I've separated out a console. We're not seeing anything because we haven't started streaming yet. There's the streaming, and you can see we do have a nice slide here. We're moving at 5 frames a second roughly. And again, if we up the brightness, you can see the max, the average, and the min. So as we move brightness up too high, that red line might start moving up, showing some background. And if we move on to blue, be nice to have some brightness and some more exposure. See that we're starting to get some background. Let's really use some gain here so we keep our frame rate higher, and take that up just a little bit more. One of the things I don't like is this color map, so let's go to grayscale. And so there's our DAPI for blue. Let's switch to red. I know that LED wants to be up there. We're going to need some serious gain probably, and also a bit of exposure in order to get some nice images here. And maybe I can focus that a tad better. Okay, so you want to see what some RGBs look like? Let's stop the streaming, and we'll take some RGB images. Now, it might be nice to add a little more green to that. Could take up the brightness or the gain. Blue seems a little bit hot to me, so we can pull him down. And we can do some panning as well. Frame rate isn't the greatest. Again, we're moving at just about 1 frame per second. Little tearing there as we move. And oops, got a glitch there. And as we play with the focus, just sort of hard to do at 1 frame per second. There we have an image. So when I'm streaming in RGB mode, I'm not updating any of these graphs. That is the latest of Matlab. We're able to do about 1 frame per second in 3 color. Is it 2-finger zoom? There are some, yeah, 2-finger zoom does work. So these individual graphics windows, you can see that they have various attributes to them that they just inherit from being in the Matlab environment. Let me take you under the hood a little bit. ls star.m. These are the M files. that are running the show. There are two update display panels. These are called by timers that do the updating of the main window. Display FPS down at the bottom here just figures out the frame rate and displays it. Do multi-frame average, do Z-stack, focus, F-stack. These are primarily the functions that are addressed or called from this advanced features menu. ls get image buffer communicates with the DLL, and it returns the next image buffer from a ring buffer. You can give it a parameter of up to 3 to throw out previous images in that buffer that will guarantee that the image you're getting back was taken after the function call. ls composite is the function that was called to generate a composite image, so he returns a RGB image. And let's see, lscon and lscontroller generate and run this console, and the controller is the bureaucrat that basically runs this. If we want to know the values of all the sliders, we can call lscontroller, give it a null first argument and a request, and he will return the brightness, gains, and exposure values on each of the 5 different LEDs, in addition to the order of the LEDs and the fact that the 4th one, which would be 1, 2, 3, 4 B or green, is on. And so if we just call, for instance, ls composite and give it no arguments, he will default to call lscontroller, extract these parameters, and then generate this image. The rest of these are low-level functions to set the gain, initialize, set the LEDs. ls GUI generates and is the bureaucrat that runs this GUI, and tile is another advanced feature here. So those are just a handful of functions, most of them very small, that handle all the busy work. And again, the cool thing is it's in the environment. Just another example of the environment. So this being a graphics window in Matlab, we can ask for the current axes. What are the children? And we see that CData is a image. So image equals answer.cdata. We'll grab a new figure window and image sc image. We've just copied the data from this figure over to here. We can take off the axes, and then we can save that as, say, a JPEG, print-djpeg, comp image.jpg. So that's an idea of the integration with MATLAB's environment. We have access. We can also turn on LS LEDs if we notice, for instance, that LED B is on. We can shut them off, and since we're in sim mode, that just generated that little sequence, sim equals true or false, and that last command would actually attempt to talk to the microscope and execute that function. I'll conclude with a final demonstration of integrating an external device with the microscope using MATLAB. The device I'm going to be talking to is an Arduino, a little microcontroller that will control a microfluidic device ultimately placed on the stage of the lumascope. The microcontroller is programmed via this code here. After a little bit of setup, the loop says if there's serial data, then read the serial data and switch based on the third character, whether it's an N or an F. If it's an N, turn on the power supply. If the command is POFF, then turn off the power supply. We will upload this code to the Arduino, and then that code will be called from Matlab over here, where we use fprintf after initializing the Arduino. We can send the commands to the Arduino, the on and off commands. So just as we did with the lumascope, we need to quit the IDE because we can't share the serial port. And first thing we're going to do is connect to the Arduino. And we are connected. If we fprintf Arduino POFF fscanf Arduino, it returns saying I turned off the power supply. So here is one example of scripting where we can take a picture, a composite image, using bright field for red, green fluorescence for the green, and nothing for the blue. So we'll make a composite image and take that before we turn on the voltage. And then we pause for a second. We take a composite image afterwards and we'll display that. So again, just executing this little script. There we have the two images, and the composite is shown. I didn't expect to plop it into the main figure here, but I guess I forgot to create a new figure for that, and this might be a little bit cleaner. Okay, so there's a final voltage. And again, we have now these two variables, vImage and vNoImage, and so were this not H&E stained sample, one could do subtraction or any other algorithm that one cared to look at the differences. Again, I do not have the hardware sitting on the stage yet. Now this little block of code will generate a movie. So it will create a movie called experiment.avi, and that movie will consist of 100 frames where after the 10th frame we will turn on the power supply. And so if we execute this script, this will take a little bit more time to run, about one frame every 3-ish seconds. And now the electronics turned on, and it's very hard to see in the bottom. Let's see if we can't get some. Fell off the sample. Should have done that in white, but you can see in the bottom of the frame we do have the time stamp in each frame. So there you have it, making movies.